do we probably just need to start at the beginning? I'm guessing there's some other. So we're going to skip the warm-up for now, because we're actually going to talk about this all together, like when we're all back in different situations. So we're going to jump all the way down here to this example. These solving equations right up here, this written work, this is examples for you of why this works. The way that we keep things equal and balanced is to do the same thing on both sides. If you had a balance scale, and you guys are currently working with like massing things in science, how they used to do it was on something called a balance. You'd put weights on one side and your object on the other side until it was equal. But if I took weights off one side, it'd no longer be equal. So what I do to one side has to happen to both sides. So down here, they've already told us, but we want to write here.
Good afternoon. Janine Williams, please come to the office. Janine Williams, please come to the office.
We have a 3 and an x. So we have 3 plus x, and that's equal to my right side, which has 11 on it. So go ahead and write 3 plus x is equal to 11. Do you have the 8-1 notes from yesterday or not yet? Yeah. It was the thing I left in school. G said, if you're caught up, do 8-1 and move forward. And yes. If you haven't done, you can go work on homework. But if you don't have any done, you got to stay here with us. So I need to see them if you're done. So we have to work to solve for our x. Here we're starting out fairly easy. What's going on with the x, or what is connected with it? What value, and then how could we destroy the value? Acacia?
1, and it's balancing out the scale.
You said 1?
Yeah.
How many 1s are up there with the x?
3.
3 of them, so there's really 3, right? If I look at all these together, because these are like each other. Like these could all be joined up and just be 3. So really I have a 3 and an x. So to get the x by itself, what do we need to get rid of? The 1s. Yeah, the 3 1s. Guys, please separate ourselves. I need you working. So to get rid of this 3, how could we do that? I'm still talking to you, okay?
I see what's on the 11 side.
This side doesn't even matter right now, actually. We're looking at just the side with the x. We want to get the x by itself to solve what it's worth. So what do you think, Brady?
Divide the 3 divided by 3.
Is this multiplying with the x? No. So here's the thing. If I divide 3 by 3, which I can, but that would also divide the x by 3 and divide the 11 by 3. And then I would get 1 plus x over 3 equals 11 over 3. That's not... Because we see that this is a positive 3, the way to destroy a positive number that's added or subtracted on is just undo it. Do the opposite of it. It's positive. We just want to subtract. So on both sides, please show that we're going to subtract the 3. And we get x equal then to 8.
On the video, you said it was something else.
No. Not if you were an 8.1. I guarantee it. I don't like the shrug of expression that says you still don't believe me. Watching a video to solve through the notes, you need to make sure that you're in the right place, because if you just thought that that had solved differently yesterday, that's concerning. So now if we look at the final question on this front page, we have b minus 2 equals negative 10. Caleb, is that hand up or not?
I don't know. I think I have an idea, but I'm not certain. If we just made the positive into a negative, wouldn't we change the subtraction to addition? So it would add the 2 together and then add the 2 to the 10.
So we have a negative 2 over here, a minus 2. To undo that, we add 2. I agree exactly with what you said. So we add the negative 2 with the positive 2, and that gives me that my left-hand side is just b now. But my right-hand side, this is where people make their mistakes. We are at negative 10, and we're told to go up
Oh,
by
so
2.
then 8.
Negative 8 is where we land. Remember, different signs, we are actually calculating the difference and using the sign that comes from the more powerful.
Got the same answer, but just negative.
So, by the way, guys, I have adjusted your Schoology due dates. 8-1 is due by midnight tomorrow. 8-2, 8-3, because we'll do 8-2 tomorrow, and then Friday we'll either do 8-3 or we'll do a different activity. But 8-2, 8-3 is pretty much really just from 8-2. That's due Sunday night right now. I might push it and make it Monday night. But right now it's due Sunday night. So 8-1 is due tomorrow at midnight, but I'd try to get it done tonight if possible. So then, moving to the back, we can solve equations the same way using multiplication or division. If I multiply on both sides or divide on both sides, this is not fun. I know. So hang out with us. We're getting there. So if I see a division happening, I can cancel it out. What's the opposite of division? Multiplication. If I see a multiplication happening,
Division.
I can cancel it out with division. So let's look right here at your first example where we have D divided by negative 5 equals 7.2. So, solve what is happening with this D. What is being done to it? Yeah, being divided by what? So how do we cancel out division or undo it? We multiply. So one way I can show multiplication is putting a parenthesis right against the number. That will let me multiply. And we want to multiply by the number that we want to get rid of. Riley, what number do we want to get rid of? Ooh, be careful. I thought you were kind of spacing out a tiny bit. Oh, that either Friday or Monday. I'm gonna do a couple alternative activities right before winter break here. So we're gonna talk about the fact that over the holidays people travel and people eat. So I've got some alternative activities coming up Friday, Monday, Tuesday. You don't eat at Christmas at all, or during. Oh, you love eating. Oh, I thought you said I didn't eat. Yeah, so
Things that are sugary and
spicy.
we're going to talk a little bit about food labels, and we're going to talk a little bit about travel and ratios and maps and proportionality. So Solomon just told us that to cancel out division, we multiply. Then Riley told us we want to get rid of the negative 5 because it's what's on the side with the D. Now, what happens when I put negative 5 over 1? It's just negative 5. Here's why I wrote it like that. If I have a value on top and a value on bottom, they cancel each other out. Over here, we can just write it as times negative 5. We don't need it to be in fraction form. That now gives me D equal to, break up the multiplication. First thing to think about, what's your sign? I have a positive times a negative. Derek, do you know what I'll get when I have a positive times a negative? When I a negative, right? Because I only have one negative involved. Then I can do 5 times 7 gives me 35. 5 times 2/10 gives me a whole. It is going to be negative 36. But I broke the problem apart. First, I dealt with my sign. Then I don't have to think about my sign. So then 5 times 7 is 35. 5 times 0.2 is another 1. 35 and 1 gives me 36. The whole thing has to be negative. I just broke it up, made it a little bit easier. Over working around the room, Brandon, what is happening to our P? It's being multiplied. What do we want to do to both sides? Divide by. Yeah, so we divide by negative 2 here and divide by negative 2 here. That gives me that P will equal, well, positive divided by negative. You know what we're going to get, Brandon? Ooh, when there's one negative, it stays negative. Remember, it's got a pair to become positive. So I either have negative 1 over 2 or negative 0.5. Make sure that you use the negative symbol,
Yeah.
not the minus symbol if you're
No,
using a
I
calculator.
used that, but I switched the process up.
You switch the process up.
Oh, okay.
So, here in the got it, think to yourself, what do we need to do to isolate the m? What do we need to do to get it by itself?
Good afternoon, Colin Williams. Please come to the office. Colin Williams to the office, please. Thank you.
Piper, what do you think? What do we want to do on both sides to get it by itself? So is that what's happening or what we want to do?
Oh, wait.
So yeah, the first thing we ask ourselves, whether we do it in our head or out loud, what's happening to the variable? It's being what? Divided. So we want to multiply, do the opposite of that division. So we multiply by the value you were trying to get rid of, and by the value that you're trying to get rid of, and that will give me that m comes out to be 5.5. Any questions? Three of these equations have the same solution. I want you, either on your own or with the people close by you, to solve all of these, write what you did on both sides, and then the solution. So I'll help you with the first one just so you get the hang of it. What do I need to do on both sides here? Caleb?
Divide, since it's being multiplied, we divide it.
So we showed division by 12 and division by 12, which gets me the answer of n equals 5. Circle it, put it in a box, do something so that we know it's your final answer. Actually, let's do this one together, then I'll have you guys release for the next 4. So in my next one, I'm going to continue to talk to people I haven't. Sarah, what needs to be done on both sides there to isolate the n? So ask yourself, what's being done to the n? If I try to read this, it'd be n. Yeah, so right now it's being subtracted, so we need to add. So we add the 3 3/4, and we have to do it on both sides. Remember, if you want, we talked about this previously, if you want, you can do that dotted line down through the equals. So then my left side is just n equals, my right side is just 5 when I add those up.
Whoa, I think I found which one's the same outcome.
Leah, what do we see being done to my n here, and what do we want to do? So that means we need to. Yeah, we have to multiply by what on both sides? Yeah, we use the number that we're trying to get rid of. So since we want to get rid of that 1.25, that's what we multiply by. So times 1.25, and we can put that over 1 if we want, and times 1.25. Yeah.
There's another one.
So that also matches. And my last one here, Zion, what do I want to do to get this n by itself? What do I do to both sides? What is being done to n at the start? You're still working. I'll give you a second.
Yeah. What did you ask me now?
What do we need to do to isolate the n value?
You do
What? So back yourself up. What's currently being done to the n?
you're trying to isolate it
Remember, stop. What's being done? If I read this, this is n.
plus you're adding.
So so it's n plus 15, right?
Mhm.
Back yourself up now. How do we stop addition from happening, or how do we undo it?
Should just like do 15n.
How? 15n is 15 times n. So you just identified addition is happening. What's the opposite of addition? Subtraction. So since we see addition, that tells me we need to subtract. What number are we trying to get rid of?
15.
So we subtract the 15. Here's why. A positive 15 and a negative 15 or a minus 15 combine to make 0, and my left side becomes n plus 0. But my right side has to do the same thing to stay balanced. And now 10 minus 15 gives me negative 5. So n really equals negative 5 because this plus 0 doesn't do anything.
That was weird.
So what our goal here is to get either the addition or subtraction to become 0 or the number in front of it to become 1. Right now I don't have a number multiplied by it, so it already is a 1 even though I don't see it. Because we know there's 1 of the n. So we've now isolated that 1n equals negative 5.
Oh,
And this is our different solution.
I was thinking that I was looking at the other one, 12n equals 60.
Yeah.
And I was trying to.
But those are multiplied. That's why that's different. It starts with multiplication. So
I was
try
confused because 15 is more than 10. So
try these next 4 on your own. Do not look up here unless you want to see a solution. Because we're so small today, I feel like we're not very encouraged to work with each other. I just don't hear people like collaborating. So since we're not collaborating, we might as well just kind of collaborate together. So I have made it all the way back around this way. Let's just loop over. So Caleb, in my first one, I already kind of gave away what we do. We identify an addition happening, so we decide to subtract. What do you get for your answer?
I just realized that.
So if you have 3/4, say like of $1, and you take away half, let's say like of $1. Ooh, 3/4, 75 cents,
Oh.
minus a half, 50 cents. So either 1/4 or 0.25. Either of these is your W value. Either 1/4 or 0.25. They're both the same. Zion, what is happening to W in this second problem? What's being done to it?
being multiplied.
It's being multiplied. How do we undo that?
You could divide
Yes. What number is it that we want to get rid of?
3.5.
What number is attached to the W?
14.
That's what we want to get rid of. So we identify what operation is the opposite and then use the number we want to get rid of. That gives me that W. Well, 3.5 divided by 14 reduces to 1/4. Or 0.25 if you do it as a decimal. Riley, now I'm bouncing back and forth. What is being done? So listen to the question I'm asking. What's being done to the W on this side? If you read that, it would be W minus. So it's being subtracted, right? So what's the opposite? There we go. So, and I feel bad. I saw that you did the homework last night, even though we didn't really formally make it through this lesson, so good work. Like, I bet you now, thinking back to the homework, I know, I emailed your mom, so it's okay. But I bet you now, does it, like, when you think back to the homework, would it be a lot easier now
Yeah,
that
I
we?
think this chapter's more easier, but then it's just like, you got everything wrong.
So, always feel free to call or text me. I know it was late last night, but like, because that due date really, like, I understand your mom's concern. It showed that it was going to be due today. She doesn't realize that the due dates are midnight, like the end of the day, and most parents aren't aware that we change the due dates on things, so I'll push it into the future. Yeah, so like, they don't realize that when we don't get finished, we push it into the future. So it's always feel free to call or text me and ask what's the due date going to actually be. But good work. You're on top of your stuff. So exactly what Riley said. We see subtraction. We then add. Be careful. If you have a -1, you're at -1, and you're told to go up by 3/4. Did we go up enough to pass 0?
No.
No. So we're at -1/4. This is the different value. Like the one where the solution is different. How up top, our last one was the different one. Here, our third one is the different one. And to wrap it all up, Solomon, what do I need to do in my last one to get the W by itself? It's being multiplied, so we need to divide. When we divide by 5, now over here, this will be easier if we write it as 5/4 improper divided by 5, which really tells me keep, change, flip, and multiply by 1/5. The 5's on top and bottom cancel out, and we get just 1/4.
Yay, I did it correctly.
Very Christmassy up here. So we have just over 15 minutes left.
Nothing about it.
I want us to be very careful as we work through this chapter and make sure that we know what we're doing. So I'm going to give you the next, and we have actually 17 minutes left, to work on 8-1. If you are behind on other homework, I care about that, but not right at this moment. I want you practicing on 8-1. If you get stuck, ask a peer first. I want you guys to start like working with peers and get comfortable with that, more so than some of you do right now. Then stick up a hand and ask one of us if you need help. So grab a Chromebook. Let's use this last 15 minutes. You can get done with this homework easy.
This is really easy. I like it.
So if you've already done it, you can work on something else if you
No,
want.
I was thinking, I'm like, wait,